It's really possible.
All right, let's connect the cell membrane. You guys don't have treaties. Okay. Now, you're going to engulf her by phagocytosis. All right. Thank you guys. Take a seat. So there are white blood cells that can do that with bacteria. Inside of those phagocytes, they have lots of lysosomes. Do you guys remember what's in lysosomes?
Digestive enzymes.
Right. So they have lots of digestive enzymes. They can literally break down that pathogen. So all of this activity in this infected area, it causes a little increase in temperature in that area, which is why if you get this infection, that area can feel warmer. Another part of the second line of defense are proteins called interferons. What does that sound like they do? They interfere. Okay. So interferons interfere. Specifically, they're going to interfere with the production of viruses. Question?
What do you say?
Yeah. Inflammation. So, interferons are proteins that inhibit the production of viral proteins. Production of viral proteins. Proteins that belong to the virus. And so if the viruses can't make all of these proteins, it's going to vastly slow down their reproduction. So you're going to be able to slow down the rate at which they're reproducing. And then thirdly, fever or temperature. So why would it be actually beneficial for you to have a temperature when you're sick? Why might that be helpful?
Well, because high temperature makes the environment for the pathogens work.
Yeah, exactly. So it can be a hot enough environment that's not suitable for the pathogen anymore. Peter?
Or maybe because if we get a high temperature, we get afraid when we start drinking many pills.
So it could be, a cause of, oh, maybe I should go look into antibiotics if I have this temperature. That could definitely be a cause and effect. Likely not why you evolved, likely evolved to kill the pathogens, but that's absolutely a modern day effect of it. You can have a temperature that becomes dangerous and can actually kill your own neurons. That would be when it gets like 103, 104, which is like 93.5 and above, like 40 and above. So at that time things can get dangerous, but lower temperatures, good for killing off bacteria. So all of these, everything we've talked about so far in the first and second line of defense, these are all non-specific defenses. Non-specific defenses. What do you think that means? The non-specific defense.
It's general for all diseases.
Yeah, it's not discriminating with disease. It's for any kind of pathogen that could be coming in. Our third line of defense is made up with specific defenses. So defenses for specific types of pathogens. We're going to talk a lot about this in our next immune system class, but today I just want to introduce it. So to be able to be targeting specific diseases, that means that you need to be able to target specific cells. And you need to be able to tell good cells from bad cells. So you want to be able to tell your own body cells from a pathogen. So on the surface of cells, we have specific proteins called antigens. So antigens, these are foreign proteins.
What proteins?
Foreign proteins.
Foreign.
F-O-R-E-I-N-G.
Oh.
From the cell. So foreign proteins on a cell's membrane. Doesn't have to be from the cell, actually, could also be on a virus. So specific viral proteins can also be antigens. So to recognize a specific antigen, your body also needs a specific protein to recognize that. These are called antibodies. Have you guys heard of these before? Yeah, maybe. We're going to talk about them again a lot next week. So antibodies, they're going to mark antigens for destruction. They're going to mark antigens for destruction. So antibody, these are the proteins that are on a cell or a virus. And then the antigen, excuse me, antibody, these are proteins in our body that are going to recognize them and tag them for destruction. Can I have 4 volunteers? Peter, actually you 3, and then Bonnie, come on up. Yeah, then you can go be a volunteer also. So antibodies tag foreign, or they mark foreign antigens for destruction. So come on up, and please line up across the front of the room. Maybe one of you guys cannot be it just because I don't have enough materials to make it work out. Okay, so you guys are antibodies. The structure of the antibody kind of looks like the letter Y. So please put your arms up into a Y formation. Okay. Each of your hands is a binding site for an antigen. So you can bind 2 antigens at once. Your antigens, if you guys would just kind of move one step forward. Your antigens are these balloons. So I'm going to throw these balloons up in the air. And you're going to have to attach them onto your bonding sites. You can only catch 1 per hand, and you can only use your hands to catch them. So,
Go down and catch me as well.
some antibodies are better than others. Represented by the color of balloon. So you can only be holding on to 1 color of balloon. So switch with people to make sure that works out.
Yeah, I'm getting pink.
Again.
Brian.
So, we'll see in more detail next week that a few different things can happen. You guys can just kind of, stay up like this for a minute. Number 1 is that, well, this is beneficial because now those antigens can't go and bind onto your cells. That's good. Number 2 is that this is a signal for phagocytes to come over and engulf those antigens. Number 3 is we also have a multitude of different proteins called complements that produce an enzyme called lysozyme, which pokes holes in the cell membrane